All right, so hi guys, how are you doing? I hope you're doing fine. I hope the weekend is being fair to you. Yeah, I really hope that. So today I'm just gonna be showing you a bit of kind of the project that we talked about, the idea that I gave initially. That's what we are going to do or work on. I'll just pause that music and then off we go. Yep, something of the sort. That's about right. Yeah, that's about right. Cool. Yeah, so we're gonna do a demo of the previous session that we did. So the previous session we did was about multi-model using the mutate. And then with mutate, you can have the same model, but models that sort of like have a dependency on, for example, OpenAI. You can have like a variety of models that stem from OpenAI and then can do like a bunch of things from it. So that's ideally what we're gonna try to do today, and yeah, hope all goes well. I haven't tried it out on my own, honestly, so I've been setting the keys so that I ensure everything is okay. So I have the keys set. I selected the model, also the base model. GPT-4 is gonna be the base model, and then I also I've extracted this here so that I use it as a uh, variable. You'll get to see where I use it. Also this for Groq as well. The other thing is I've already passed the envs here. So if I come somewhere here, you can see that I have my API keys there, but I'll delete them after this session, definitely. All right, cool. So we'll get direct into it. So we're supposed to model this application in various ways. One is we're supposed to have like it's just like the application we saw that was working with cloud helped us like come up with an idea that we could build to better understand the aspect of multi-model, having multiple models in your application, and then the orchestration depends on the kind of role that they're doing. All right, so yeah, so we gotta start modeling the whole app. So I'll just come here like that. I just say here we have a model, but I'll have it an model like this, a model dot, and then this one is gonna be an enum. So what this enum represents is the different roles that the model can play in our system. So we have a model that can generate code. Okay, sorry, I forgot to show you something else. So I'm using Spring 4.0.6. Spring AI version is 2.0. This kind of the snapshot. And then I also have like two dependencies here. So I have the web MVC and also have the AI starter model from OpenAI. So that's what we're gonna do. So I have an enum here, and then this enum, like I said, what it does, it uh, defines the let me just use the word task or capability that our model would be having. So I need to zoom in a little bit, I guess. Yeah, that's about right. Yeah, so that should be okay. Yeah, so I'll start with the first one. Okay, coincidentally, so we have first. So this one has the capability of handling fast operations. This one, we're gonna base it with Groq, but we'll get to see how. We have the first. I also have the one that is responsible for generating code, and then lastly we have one that is best for reasoning. So with fast, we definitely go for a cheap model that just like answers very simple factual questions. And then for code, we go for a more intense model that is specialized for code, something like code generation. So that's what we definitely are going for. And then for the reason one, we need a model that could reason even better. So that's why possibly the reasoning one will go with this one here as the GPT-4. And then yeah, I'm also using a free API key, so I don't know if it's gonna work out. So I'm just okay. I'm just praying that things work out as we progress. So yeah. Then after having the model, maybe I should rename it to model role so that the naming is a bit clearer. Uh, yep, something like that. Model role. I select so model role. So shift F6. function. Okay. All right, all right. So yeah, we have that one, and then the other thing we're gonna need is now the router. Uh, yeah. So we have the model. I will get to see what it does. So I'll just have it on a package called router. Like that. Okay, so what this router is gonna do, we're gonna take in the model role where it specifies the role like we've defined here. We take in the model role, and then from the model role we can now route the functionality, or we can extract keywords from it like we saw last time. So it could be some keywords that are related to code, and then others are generic keywords. So yeah, I'll just take in some things here. So this one here, this one helps us decide which model role should handle a given question here. This one help us define which model uh, handles which task. I don't know, something of the sort. Yeah, so this one is going to be a component. Yeah, this is a component. And then in here we have to define, so we just use very simple keywords to define what the model would look like, and the matching patterns. So yeah, so I'll just pick this one here. So I have already this, I had prepared this some of these things. So yeah, I need to import this one. Yeah, that's about right. Yeah, import it. So we should do a minus here. Yeah. Also have this one here as well. This one. So this is the code keyword. These are the reasoning keywords. But of course, in a production system, you definitely need to replace this with something better, like an LLM-based classifier, or just use the cheap models to classify. And then after you classify, it would route the request from the user into the right model. So it depends. So this one is just like hard coding things, but for a production system, if you have like more money for API keys and whatnot, you can have a simple model. The first model, taking the request from the user, and then it can now route it to a specific one. So yeah, this is just like because you're doing something simple, and then yeah. So have I missed anything? So we have the keywords, we also have the reasoning keywords. So these are the code keywords. Yeah, that's about right. So now the next now thing that we're gonna do is how do we classify? So we need a method. We need a method to classify model role, and then yeah, where's alt enter. We're gonna say classify, and then classify. We're gonna take in the user input or the question from the user, like this. And then what we're going to do here is first we need to normalize. So we'll normalize the user question. Okay, so how do we normalize? So we just take the normalized question equals to just have it as question dot to lowercase, sorry, dot to lowercase. So you can pass in the local dot root. I normally wonder where it does here. Useful constant for the root local, the is the local whose language, country, invariant empty string. This is regarded as the base local for. Okay. Yeah. We normalize the question, and then from there, we supposed to do now check if the word now is supposed to check the if the keyword uh, uh, yeah, we're supposed to check whether the keyword exists in our lists we have a list of keywords, so we're supposed to check whether the keyword exists in our list. So what we're gonna do is we just have public boolean contains contains any, like that, and then we have a word, we have the keyword, we check whether this keyword is in this list. So list list of string keywords. So all we're gonna do here is we return keywords that contains so okay, so keywords, we want to check whether the list of keywords contains what we want. So keywords dot say string here, then dot do we have any match, do we have any match, and then which is the keyword. So we're supposed to pass in the string this keyword, or okay, so we need say this is a text, so we want to check whether the text would contain any keyword. Yeah, we could also extract this into a lambda, but yeah, we just like use method reference. So ideally what we're doing here is we're checking if this keyword, so we stream the keywords, and then we try to find any match, whether the text contains like any of this. So here we'll just say if contains any, we pass in the question. No, we pass in the normalized question, and then we pass in the we go with first the code keywords. So if contains the code keywords, are we supposed to return which model? We're supposed to return model role dot code, model role dot code, like that. I'll just paste this one here. I'll copy this, bring it here like this. If it contains what reasoning keywords, if it contains the reasoning keywords, we just return the reasoning model, and then otherwise we just return the model dot first as the option. Yeah, so this is our router, and just a summary of what it's doing is we have the keywords that define the code keywords. We also have the keywords for reasoning, and this just like a sample, a very short list for demo purposes. So what is going to contain, and then now we need a function that will take in the question, and then from the question it now returns the model that can perform that specific thing. So we first start with normalizing the question from the user. We just have it as lowercase. You could, this is optional, the local.root. We also have this method that checks whether this list of whatever keywords that we provide has, there's a word that tries to match this text. So is there a word that has this text in it? And then yeah, that's ideally it. So that's our model router. And then like we said, so for production applications, you possibly need to have, you could have the first model acting as the router. So it takes in the user response and the user input, and then figures out whether it's something that needs code generation, whether it's a reasoning, or whether it's a combination of both classes. So yeah. So the other bit that we're gonna do is now we're gonna start now the configuration. So this is where all the patterns come together, and it's kind of the most important bit of this application. So we're gonna have it here. So we have the say model configuration. Just say config dot multi model config. And from the keyword, it's a configuration, so we're gonna have it as a configuration like that. And then now we start configuring. So what we said that we are doing here is we now have to configure the 3 chat clients. So each is backed by a different model configuration, and then all of them derive from the auto-configured base of OpenAI. So, and then we're just going to see how the mutate thing works, so that you get to see how it works. But also, something that is very important to mention is that without using the mutate functionality, you'll have to duplicate the setup for the HTTP client. If you have retry policies, interceptors, and whatnot, you'd have to do them repeatedly. So yeah, we're gonna because from the example we saw last is we'll definitely need to pass a different API key if you need a different variation of that model. So I'll just say private string. Yeah, say private string. This is Groq API key. So where is that? So where is this? So it'll say value there, and then this we have the dollar, and then where it comes from is the app dot Groq.api underscore key. Oh, I missed something. Yeah, so we got it here. And then we also need the other one for OpenAPI. So you just say here it's in $sign. I also need this one. Say app.openai.api hyphen this. Okay, yeah, it exists. I'm normally shitty in typing when it comes to demonstrating. So string OpenAI API. Yeah, so that's that. And then what else do we need now? We need now the model for the mutation. So we need to figure out how we get the chat client. So we'll map every chat client with a specific we'll map every role with a specific chat client. So the unique thing here we're looking at is the model role. So we'll say public what is a map is a map of the model role. Sorry about that. Map, it's a map of the model role and the chat client like that. Yeah, and then so here is a chat client by it's a map, so it's gonna be a list possibly. Okay, so and then what we need is we need to pass the base open AI chat model. Yes, so this is the base chat model. And then we also have the open AI API base open API. Yeah, that's about right. No, there's something I'm figuring out that I should have done like ages ago. Just minimize this one. So I'll just put it this one here, and then this one would come somewhere. Yeah. And then now, how now do we configure all these things? So the first step, like we saw, is we're supposed to derive the the first one. So derive the Groq model. So here let's derive Groq. How would Groq look like? So we start with the API OpenAPI, we say API. It's a Groq API, so it's a Groq. Groq API. I keep messing these things up, you know. Groq API equals to what we use is we use the base chat model, and then we say dot. Is it? Oh no. Is the base OpenAI API, and then we say dot, and then after the dot is we need mutate. Yeah, we need to mutate, or we just say here dot mutate like that, and then here now we just need to pass the a few things. So the first one is the base URL for Groq. The base URL for Groq is HTTPS. Let's Google. Groq base URL. Yeah, so yeah, should be this. Yeah, should be that. And then we also need the .api key, and then here we just need to pass the Groq API key like that, and then we just need that .build. So what we've done here, we've derived the Groq API. We have derived Groq, and then the next thing that we're supposed to do now is we derive the three option, the OpenAI chat model. So we need the OpenAI chat models. Okay, so the first one is the first role. We have the natural sounding, which just look for short answers. So there is the first role for Llama 3 on Groq. So this is a chat model. So we say OpenAI chat model. We call this a first model. First model equals to we have the base chat model like that, and then we say a dot. When we say okay, we're supposed to use the mutate. I keep forgetting this. Like this, and then we start now. The default options. We say open chat options dot builder. I don't need this one here like this. Yeah, import it, and then yeah, I will say dot. So the temperature. So this is the first model. So 0.5 would be fine. So it's in between there. We also need the model. The model is gonna be we go with Llama 3. Yeah. What else do we need? The maximum tokens to be used. Max token would be something like, so this is the default options. Okay, get the OpenAPI spec for it is gonna be Groq. Groq API. So the default option, yeah, need that at the end. So we specified that. So this is the first model. So we also need the other model, which is the coding model. The coding model is gonna be I'm just gonna do this one here. The code model is that. So I'm gonna change here to GPT -4 like that. That's gonna be we need more tokens, 1024. The temperature is gonna be, so it needs to be more deterministic because this is code we are generating. and then yeah, that's okay. So the other bit is the reasoning model, but here now we don't need this because we already have GPT-4, so we don't need to use the Groq as the API. So for first model, we'll go with the Groq, but this one, it will default to whatever we provided here. This one default to that. We also need this again, so we need for the reasoning model, and then yeah, so it's gonna take the same thing, but now we just need to change the temperature so that it becomes more creative. So this is the reasoning model. So here let's go with 2056. If that's 2056, it's normally 48 here. Double of that, so it's gonna be GPT-4 still. That's the model, yada yada yada, and then yeah. So how then do we get the chat client? So we'll say chat client, and then we say the first client equals to, we build chat client builder dot build, and then when you say this, you can pass in the model. So inside the builder, you see we have a builder that passes the chat model, so you can pass the first model, and then you can do a dot build. Let's just build it first, and then you can specify here the system prompt, the default system, and then let me just paste in some code here. Yeah. No. Let's just use a string template. Yeah, so that's for the first client, and then you can create another client for the code client. The code client, we take in, it's gonna build from the chat, the code model. We take in the system prompt for it. We're gonna put it in here like that. I'll definitely do the shift terms here. And then we have the last one, which is this one here. So I'll copy this. Yeah. I'll do this. I'll say control duplicate. Yeah, that's about right. And then I'll do that. Do this. Okay, so this one is a reasoning client. So passes the reasoning model. And then what else? What is the last thing we're supposed to do now? We're supposed to now return a map that contains all of them. So return immutable. So when you say map.off, it means that you're returning an immutable map. Yeah. So again, this is going to be a lot of code. So model role dot. We can start with the first one. And then its chat client is going to be a first chat client. Yeah, and then we need a comma. We have which is the second one? We have the model role dot code. This one here is going to be the code client, like that. And then we have the model role dot reasoning. We're going to have the reasoning client there, and then afterwards we do that. So yeah, this is how we configure a variety. So we just have this one from Groq API. So yeah, you can get the API key from Groq. So if you hover where, if you come to Groq, actually I saw the link and then ignored it, man. Oh my. If you come here to Groq, you'll get access to it, and then you can get an API key that you could do a bunch of things with it. So you just come to API keys, create an account, and off you go. You get an API key. So then the almost last thing that we do is we need a service. So this service is the one that takes in, say, a question, and then it reconfigures, or it routes to a specific model. So just say service, and then say something like a smart assistant service. Yeah. So we annotate this with the service like that. And then now what we need here is we could try log. So private so static static logger log equals to say logger factory boy logger factory logger factory dot get logger, and then we log for the smart that class. So this is where we are. Yeah, for some very weird reason, I don't know what's happening. I got the from Self4j. Yeah, so the other thing we need is the model router. So private, so private private final model router. So this one is the one that takes in, helps us like route the whatevers. And then we also need one last thing, which is the component that we built, private final map of the model like that, and also the chat client, so that we know what is being used where. And then here we get the clients by the role. So just press Alt Enter, we import them, and then we can inject them via the constructor. Yeah, so that's about right. So we now just need a method that returns a result. So I'll just create a record here, a record that contains the answer. So I'll just create this public record. This record is gonna be called the answer result, and then the answer result is gonna contain the following. It's gonna contain the model role. I need to go back to the typing classes, and then also contains the string, the answer or the response. Or let me just say let me just call it the response. Response. So model role, the response, and then you also have the latency. You could have the latency. And yeah, that's about it. So we have that record, client by role. So I have an issue with this. So it's saying will not outwire the bin. So yeah, so this should be a bin. This should be a bin. Where we have that. This should be a bin. Yeah. And then yeah, that's fixed. So we have a method, say public, and then this method, what it's gonna do is returns a response. Yeah, I could rename this to forgive my mind. The model response, say get response. So here we're gonna take in a question, the question. So we're gonna take in a question like that, and then after taking in the question, so the first thing that we need to do is we need to, based on the question, we need to retrieve the model. We say model role, the model role, and then say the role equals to the model router, model router, model router, model router dot classify. So it's gonna return the thing that we want, like that, and then from there we can just like log log.info. Let's log a little bit here. So we say routing the question to which role. I'll just have this one here, and then we can have the role. You can also have the question, say for, or you can just type it. Where is the pipe? I will pass in the question equals to that is the question, so that's okay. And then the other bit that we need is now we extract the chat client. Chat client equals to what we do is we have the client by role, so it's supposed to be client, sorry, clients. We need clients by role, and then say dot yeah, we're supposed to get, so we're supposed to get dot get, it's a map that is returned, but we need to extract it from the role. Our role is the key, so after extracting it, we can start the timer instant. This is just okay, this is just to try fancy some things. Say instant dot now, it started now, like that, and then we can now pass in. So this is when we want to perform the actual LLM call. Depends with how you want to do it. You want to do it, you want to stream, so that's when you could possibly use the time, or you want to use uh the synchronous way. So it depends on what you want to do. So we'll just get the answer. The answer equals to the client dot prompt, and then we say dot user, that's the question they ask, the question, and then say dot call dot call, and then dot to entity, no, dot content, like that. And then what is supposed to return now is model response, and then what this model response contains is a new model response, and then the model response contains the model role, so we just pass in the role, the answer, so this is the answer, or just the response, so I'll just call it response. I will just copy this here, put this one here like this, the response, and then we could also pass in the latency. So for the latency, because we're dealing with duration, period is when you're dealing with years, duration is when you're dealing with time. So duration equals to, so when does it end? So after that call, so we'll say duration dot between the start and instant dot now. So when the call has ended, like that. So yeah, we could just pass that here. We say the duration, and off we go. Off we go. Dot 2 millis. Yeah, 2 millis. All right, and yeah, we have something like that. Yeah, that's the simple. So the last thing we need is the entry point. So we'll just come here, create the controller dot assistant controller, and then so this one is a trust controller. So and then we have the request mapping like that. We have slash API slash v1 slash assistant. That's about right now. And then here we need to inject, so just say private final smart assistant service. Just say call it a service like that, because I don't wanna. I'll say alt enter, no, alt enter the constructor there. That's all good. And then now I need the first one. So I could make it a post, I could make it a get, I could make it anything I want. But yeah, so I could just pass in the question, and let's see. Uh, so we have the service. This one takes in a question, so it gives us a response. Oh yeah, so yeah, I could just do it directly. Say I could have it as a get, or a post or anything. So let me just say post mapping, and then assistant we can say slash ask, and then we have a response entity, so we say public. Let it return a string. Wait. Model response. Contains the answer. Yeah. Yeah, that's gonna be a bit weird. Yeah, that's gonna be a bit weird. Okay, let's see. We're gonna say returns a model response. Model response. Yeah, just get it from there. I'll import it. Oh boy. Okay, so you'll have to bear with me. So the naming, there's a model response that exists in Spring AI. So I might as well rename it to something else. I might rename it to custom. Yeah, so that I can import it. Oh boy. I can copy this, put it there, and then say dot like that, and then off we go. So here we just say ask, and then we have at the request parameter. So our request parameter, we have a string question like that. I wonder whether it pressed start recording. Oh boy, thanks. Yeah, that's the question. And then what else? So here we're supposed to say service, so we're supposed to return service dot ask, service dot get the response. We pass in the question. like that, and off we go. So everything is set. So I might as well just run it. I might just run it. I hope I've not missed anything. So let's. Yeah. So it started. It started. So I'll just come here, and then over here. So what I'll do is I'll have different variations of the question. So I just say I'll just say something like, so I'll just copy this question. What is the capital of Kenya? Like that. So let's see which model generates the answer. I get a 500. Oh, what a beautiful day. The model Llama 3 does not exist, or you do not have access to it. Okay, okay, okay. So, okay, Llama 3, let's see which config was that. So if it goes to Llama 3, it means it's a fast model. So yeah, that's kind of a fast question, you know. So yeah, so I guess I'll have to check the models. Let's just check with you. Uh, docs, docs models. Uh-huh. Models. Not whisper. I don't want to whisper. Create transcription. No, I want models. So with models, I have list of models. Llama this. Let me take this one. Oh boy, models. Okay, let's see from the docs. Llama, this one. That's on me. Yeah, so I'll rerun. Yeah, it started. So we run it. Oh boy. So what do we get now? So the model has been decommissioned and is no longer supported. Spring AI, I guess I have a pull request. So I never showed you guys I have this Spring something here. It means that I can create a PR on this developer documentation. Yeah, so Spring, this one is no longer. Okay, you reckon? That's impressive, no? That is impressive, man. So don't mind me, I was just trying to see whether I have the accent of the UK people. I just love their English here. So it's like the model is not kind of there. So let's try get something else. Let's try this one here. But I see it here. It's here. Llama 370 billion parameters. Okay, let me just zoom in so that you guys can see as well. So because it can't, so let me just take this one, the one for 8 billion, and then I'll just paste it here. Oh my guys, oh my guys. And then Control Shift, take it there. Yeah, just rerun it and see. I hope things work out, you know, for the better. I still get it. Has been decommissioned. Now what? Deprecations. Why? Oh, why you they do like that? Why you they do me like that? Okay, so let me take something else. I'll go for kind of this one here, this instant. I don't know if it's the whole llama thing that has been decommissioned. Uh, so I'll just distill owned by Hugging Face. Okay, so let's try this one. It's just a matter of trial and error. As you can see, it's routing to the first model because it's kind of like a simple question that, yeah. It's a simple question. So it routes to the, yes. Vamos! I'm a football fan as well. So we get the response, which is like so amazing, so cool. So the latency in milliseconds is 1493. It's a fast model, and the answer is Nairobi. So I'll just try it out so that we, yeah. Also in 381 and 529. So yeah, the first model. So that's our first test has passed. Yes, almost. Okay, so we'll try the other question. Write a Java method at this. So let's try this one. I get an internal server error. GP4. GP4. Oh my god. I was creating my own models. GP4. Okay. Alright. Okay, let's see. So what we're gonna do is we're gonna try this one here. Oh boy. What's the issue again? You do not have access to it. Oh boy. Oh boy. Yeah, I'm pretty sure I don't have access to it. I'm pretty sure. Definitely sure. I do have access to it. And then that sucks. Yeah, 404. The model GPT-4 does not exist. With root cause, non-transient. Uh, what I'm gonna do is I'm gonna come to the documentation, Spring AI, and then I'll click on OpenAI. Where's OpenAI? Man, they could be giving out free credits at least so that somebody can try it. Uh, GPT-4, OpenAI. I just want to pick one model. Uh, GPT-4. Oh, so what I'm gonna do is I'm gonna ensure that I try to be consistent with how I'm doing all these models here. GPT-4. Oh, and then where else do I have this? I have it in the model router. No, multi-model config. This one as well. Reasoning model, yeah. So let me rerun. Man, I hope this thing works out, man. Yep, started. So I'll run it again. Hope it works. You exited your current. Man, I just made 2 calls, man. Two. Just check your. Yeah, it means I have no. I have no. Man, it sucks to be at this point. So I don't have like API keys due to financial crisis, yeah. And they don't have free whatever. Let's see. OpenAI AI free. Or let me do this, yeah. Let me get an API key from somebody in a second. Yeah, so I just called my friend and he's given me an API key. So I just cancel and apply. Yeah, yeah. I hope that is not the whole API key. Hope, let me confirm. Yeah, that's not the whole of it. Okay, so I'll rerun the app. I'll rerun the app so that you get to see. But yeah, I hope it works. I really hope it works. So we wait for. Oh yeah, yeah. So this one is code generation, so it works. So it's routed to that. So to reverse a string in this, it utilizes that, yeah, that, and then gives me code. So of course there is a lot of formatting that needs to go here. This is just like a backend thing for you to format this, and then the latency is given here. I could try it again, and yeah, it honestly works. So it knows that that's a code generation thing. So I'll move on to the last request. The last request is this. So how does it know what it's supposed to do? Uh, yeah, something like that. Yeah, and you see that this is reasoning. So when deciding between a monolithic architecture, each architecture has their own trade-offs and whatnot. But yeah, I hope that you now get the idea of what we are trying to do, and what the mutate method does for us. So it just like allows us, or it enables us to have a way to route the, depending on the kind of question that has been asked. So as we can see, we have a Groq API here, and then there we have the API key and whatnot. And you can see that if it's something that was the default uh, uh, okay, the default model is GPT-4o, and that gives us the coding model and the reasoning model. So I decided to use both of these, but you can get when we did the routing, we got a different role that it was playing. One, it was playing a role for reasoning. The other one, it was playing a role for coding. And then if you want something that's faster, you don't want to use GPT-4 for like such tasks. You want like a very simple task, you could use a different model. Of course they're stemming from OpenAI, but uh you can extend, or you can get one from Groq, and you've seen that this is where Groq lives, and this is where you can get the model. So if you want to get an API key, you just like click on the API keys. You have to create an account and whatnot, and then you'll get something at the end of it. So yeah, that's the demo. I'll push this code to GitHub so that you can also try it. And then the next thing we are going to do is now possibly just like dive into prompts. I get to see how prompts look like, how you could create simple or better system prompts and whatnot. And yeah, so thank you for watching up to this very end. Thanks to Cloud as well for helping us or coming up with an idea that could help us understand how this happens. And it's always best for me to, as I continue learning, I'm trying to see, as I learn a concept, can I translate it into a project? So if I don't know how to translate it, I'll ask AI to help me. And like I said, what really matters for me is I don't care what I've used. What matters for me at the end of the day is, do I really understand what happens there? So I'll just use Excalibur. I'm just gonna do a summary of what we've done. But the bottom line is you have this thing here, you have another one here, you have another one here, and then you have another. So I'll call this person. This person is the user. Um, should I call this is the user? Yeah, the user comes with their question. So this is the user question. Gets to our router. So of course, before it gets to the model, the HTTP intercepts it and whatnot, the controller. But before it gets to the service, we have what we call a router. So this is now the router. And then from the router, it takes it to the service. So user comes in with a question, their question is forwarded to the router, and then the router has access to, like, it could configure various models based on the base model that it has. So configure the router, that's okay, and then the router takes in the user question, and like I said, you can have various ways of routing these things. You could use an LLM for extensibility. Just use an LLM instead of hard coding thing. an LLM with minimal charges and whatnot. So it's just like a very basic fast model. And then this fast model translates your response and then it routes it into the service. So once it's routed, we already come out of here with a specific role. And yeah, that specific role is used to generate a client. So this is the chat client that we use. And then this client is now responsible for acting. It takes the refined. So we have the refined. Everything is refined now. We already know which model to use and whatnot. And then the chat client helps us make the call to the LLM that we want. So yeah, that's the whole ideology between all that. And then the method that helps us perform these things related to routing is the mutate method. So you have one starter, but it could be configured to various things. Yeah, so big shout out to Felix Jomason, aka Blackie, for the API key and for the prompt answer to at least make this tutorial a success. So that's it. If this was helpful, just like, you can subscribe and also share with people around you. Thanks so much for tuning up to this very end. Have a lovely day. Bye.